We're going to move right on to the next talk by Max Kahan. Max is a Python developer advocate and software engineer at Vonage, ex-IBM. He's interested in communications APIs, developer relations, machine learning, and open source, developer experience, and dancing. His training is in physics, and now he uses his problem-solving skills daily, working on open source projects and finding better ways to make developers' lives easier. So I'll give it away to Max for Fear the Mutants, Love the Mutants.
Thank you for coming here. I know you've been here all day. I've been in the hotel room banging my head against the wall trying to get this done. So I'd like to just explain what this is all about. So my name's Max. It's wonderful to speak to you today. You can probably tell from my accent I am not from here. I've journeyed many lands, put it that way. But I am here, and I'd like to talk to you about mutation testing. Does that sound good to everybody who's here? Yeah, more of that. You may notice now, but this is going to be an audience participation heavy session. I'm sorry, it's the only way I know how to do this. So if you don't like that, there is another room, or just ignore me, tune me out, but I will be loud and annoying, so if not, buckle up. Right, so I work for this company, and I'd like to thank them because they've paid for me to come here from England, so thank you. Just explain very briefly what they do. So we do stuff with communications APIs. So if you're interested in things like SMS, like voice calls, video chats, meetings, like verification, two-factor, stuff like that via API, come chat to me. I'll give you a coupon code. It's all free. It's all good to try stuff out for free anyway. But, shout me. I've got stickers. You name it. I'll throw it at you. So that's what we do. But the other reason I'm mentioning the company is not because I'm talking about them today. That's the bit I talk about. I'm good now. I've covered my flight. But what I'd like to do is just explain that what I do is I maintain our Python tooling. That's why I'm here. And last year, I actually applied mutation testing to our SDK, to an SDK that I manage. And that's kind of why I'm talking about it today, right? So I'd like to introduce our protagonist, because I am not the protagonist. I am loud, and I will be jumping up and down and sort of getting in the way of people and doing my best to do that. But actually, our real protagonist here is Henry. Hands up if you think this is an adorable penguin. Okay, every hand will be up in the room, thank you. If not, you don't have a soul, but that's okay. So Henry's wonderful, and the reason he's here is because as I was learning about this topic, as I was doing all this kind of stuff, I came up with these analogies and these ways to understand it for me, and what I'll be doing is sharing those for you as well. So, because this is an audience participation session, hands up please, who's heard of testing? Okay, I'm at PyCascades, thank you for just checking. I'm not in a different conference, great. Slightly more useful one. Who's heard of code coverage? A lot of people, not everyone, but that's okay. You don't have to have, we'll talk about it, but if you haven't, that's fine. If you have, awesome. Final one here, other than via knowing that this session exists, who's heard of mutation testing? Okay, a little fewer. Keep your hand up if you've used mutation testing. Okay, most of the hands went down. Tony, I know you did. Awesome, so hopefully by the end of this, we'll inspire more people to try it out. So, what I'd like to do is just take things a little bit back to basics and talk about testing in general before we get there. So quick question for everybody here. Why do we write unit tests? What's the purpose of unit tests? Anybody, shout at me. Hands up, whatever, just make noise. Why do we write unit tests? Make sure we don't break something. That's a good one. Check the correctness. Okay. Get paid by the line. Sorry? Get paid by the line. I couldn't hear that. I think it's the... That's fair. That's not a reason I have on the next slide, actually. I'll get that one for next time. We get paid by line of code we write. Let's do some more testing. Yeah, I like that. Well, I've got a few reasons here. So one of them to prove that your code works, right? You know that we've said that. Also, as documentation, testing is documentation. Also to inspire confidence that we know what we're doing and that we trust that our application works as expected, right? We also care about regression testing, refactoring, and also compliance reasons. Like sometimes there's a legal requirement to do this. So these are all valid reasons to do some testing, right? There's a bit of a problem with this, though, right? Is that projects, they start off small and lovely, and like your children, they start off lovely and lovable, and then they grow and get annoying, and they get a silly haircut, and you're like, you don't go around dressed like that, and so on. So we end up with a situation where they've evolved over time to do a lot more than we actually said they started to do. And we also can sometimes miscode when we're doing refactoring, which does get in the way as well. That becomes a problem. And so we end up with a situation where we don't often monitor our tests properly. So luckily, there is a solution, right? Code coverage. We all know code coverage, or at least a lot of people do. If you don't, essentially, it's how much of the source code of a program is executed when a test suite is run. That's my definition. It's not one that I'm not going to claim anyone else came up with this because it's not a particularly intelligent one, but it's my definition. And that's hopefully a summary that explains what it does. But what I'd like to do is give you an example from the SDK that I've been using it for, right? So with my messages API, so in my SDK, we do communications APIs, and inside of there, whatever, it's an SDK. It's on GitHub. Look at it if you want to. I don't mind. But we have some code that lets you do messaging, right? And this code here, this is a code coverage output of this. And you can see here that I've covered most of the statements, but I'm missing one down here. I'm missing a type of authentication. I'm not testing with this authentication type. And looking at code coverage, I can see, hey, I'm missing this. I've got to add that, right? So I do. So I add it. If my clicker works, I've got to point out the thing. So that's what you do, right? So it's code coverage has identified a problem for me, and then I've gone and I've fixed that problem, right? And that's kind of where we want to be. What it can also do, this is a very creaky stage. I'm not sure if it's being picked up. I feel like I want to tap dance or something. But either way, what we have up here is an output of all of the different files, all the different things in my code base, and I can see how impressive they are or how not impressive they are. It tells me where to focus my attention and my efforts, right? And so that's useful. And it's got some really good stuff about it. So it helps you write more and better tests, and it can also help you, because it's easy and cheap to measure, it also can show you what you didn't test, right? So this is awesome, right? Code coverage is great. In fact, code coverage is so great that actually, thank you very much. This has been wonderful. It's been great to talk to you, and I will see you again. Thanks for, except actually, there is some stuff that's not so good about it, so maybe I should stick around a little bit more. So one thing is it can be a little bit misleading, and it doesn't guarantee the quality of your tests, right? So one thing I'd like to show you is just a quick example. Here's a very small function. It's not super complicated, but what it does, it just makes an API call. It just calls to this random URL, right? I'm going to show you a piece of test code now that has 100% coverage. You might see this isn't very useful. All this is doing is basically calling that function, and if anything is returned, you're good. Now, this isn't ideal. This isn't ideal because we don't know what's returned. It might be that we've returned a 404. It might be that we've returned a 200. We don't know what's happened. All we know is that the thing ran. And that's not good enough for our use case, right? If we want to know what's actually happened in that API call. We're not mocking this. We're not doing anything useful. And so this is important to think about. So there is a principle that sort of summarizes the challenges we often have with code coverage, right? And that's called Goodhart's law. I don't know if anyone's heard of this. It's kind of from at least one person. So as soon as I say Goodhart's law, someone's like, yes, I know what that is. I respect the energy and the enthusiasm. I love it. So what Goodhart's law is, I'll just kind of summarize that, is that basically when a metric becomes a target, it stops to be a good metric. So if you're focused on getting a certain number much higher, you're not focused on what the number is telling you, right? And I'll just say, let's just be honest here. Okay, show of hands. Again, audience participation. Put your hand up if you've got a code coverage target and you've written a test just because you want to make that number reach your target, even though maybe the test wasn't super useful. The back seems to be a lot more honest than the front. Thank you everybody for responding there. So this is things that I've done it too. You know, no one's edited here. We're in a safe space. But it leads to this question that I'd like to ask you. How can we understand what our tests are really doing? Open question. Read them. Break them. Anything else? Test them. Oh, sorry. Well, that was louder than I thought it was going to be. Okay, well, while we muse on that, I'm going to drink some water. Talk amongst yourselves. Thanks. That was great. You can stop now. So this is all really, really valuable points, and you can break them, you can test them, you can read them. These are all things we can do, and it leads to another question, which is, I won't ask this one out this time, but how do we know that they're trustworthy? And really, these questions, how do we test them? And this was really summarized quite well in 100 AD by the Roman thinker Juvenal. After a fourth glass of wine, it was a heavy night, and he woke up the next day having just actually summarized this problem really well. And what he said was, who watches the watchers, right? Who's testing our tests? Who's looking after the things that look after us? And the answer I'd like to propose to you is mutation testing. Spot the odd one out. Alrighty. You might have noticed, if you're quite sharp-eyed, that Henry has made an appearance again. And the reason why I'd like to explain, because When I was learning this stuff, I was thinking about it and conceptualizing this because my code does API calls, right? So I imagine this like a pigeon or a dove, something that's like a bird that can fly, right? And what I do is I tie a message to its leg, and what I'll do is I will send it off, and I'll let it go into the world and send that message for me. So it will fly away and do that thing. Now, fun fact about penguins, they are birds, so they fulfill that criteria, but they don't fly, and it makes them angry. But they're really not the tool that we need for this. And so when I think about mutation testing, I imagine my production code with some mutation operation to change how it operates and become something else, right? This is really what mutation testing does, is it takes your production code and it creates some mutants from it. So an example I'd like to give here is, for example, the add function here. This is very, very simple. All we're doing is we're adding two numbers, right? A mutant version of this might, for example, change the operation that's actually being done. It might add a constant. It might change the types. It might return nothing. It might do one of a number of other things as well. So there's a lot of things that this can be doing. And with mutation testing, what we do is we take all of these different versions of the mutants, or as I call them, the Fab Four. You take these mutants, and what we've got to do is essentially see if they can fly, right? We've got to test them and see, are these penguins or are these birds that can fly, right? And so this is what we do with this incredibly adorable DALL-E-generated image. So we see this by running against our test suite each of these mutants, right? So there's two things that can happen here. The first one is that the test can fail. And in that case, we say yes, because what we've done is we've exposed Henry as a penguin, which is what we want, because unfortunately, he's not going to be able to do our messaging for us, right? Alternatively, the test can pass. And if they pass, that's kind of bad news, because it means that this penguin is convincing enough that it managed to get through our unit tests, right? And this means it's a bug that could have made it into production, right? That's the bad case. So what does this give us? This isn't one for you, this is one for me. I'll assert this quickly. I assert that this gives us a way to evaluate the quality of our unit tests. So that's the sort of very conceptual overview that we'll refer to. But for now, let's actually get down into the weeds a little more. Let's talk about frameworks. So in Python, it's not sort of, there aren't big enterprises like there are, for example, for Java with PyTest or for Striker with things like C#. In Python, we have some community-supported stuff. We have these two repos, Mutants and Cosmic Ray, that support it. So I'm not a professional here. I'm not a doctor, lawyer, or professional financial advisor. Your investment value may go down as well as up. But I've personally been using Mutmut. And I gave this talk in Belgium last month, and the organizer got very angry here. I asked why, and he said, I wrote the other one. It was a bad time. But that's not a joke. That really happened. It was very embarrassing. But this is the one I'm using, and the reason for me is that actually it's quite easy to get going with. It makes kind of sense like quite quickly, which helped me. So applying this to my SDK, all I really needed to do was do it locally first, which I did with a pip install, and then mutmut run. And that was kind of it to get going, right? It's not a super complex thing if you've got sensible defaults. So honestly, have a look at this. But yeah, when I ran that, you can see it generated a whole load of output here. But actually, what it does is just explain what it's doing. So first of all, it runs your tests, and then it will generate those mutants, and it will run your test suite against them, right? The output that you get here is that you can capture those mutants. They can time out. They can be a bit suspicious because they took too long, or they can survive. And in this case, when I ran this, what I found was that it generated almost 700 mutants, of which it caught about 500, right? So not all of them. There were a lot that didn't get caught, but it did catch a significant number. So what I think we should do as a team is let's look at some mutants. So you can do that, which I'll show here. So you can see here, we've got this is from our messages API. It just says message things that are allowed to be done. And the mutant version just changes the value of one of these, which means basically that when we try and send an SMS, it will fail. And so this is one we caught because obviously our tests are going to test that. There's another one here. This is, has anyone used Pydantic? A few. Awesome. So this is, we use Pydantic a little bit in our SDK as well. And this is from there. That's from one of our models. And we can see that the mutation test just removed this decorator, meaning this would never be called. And again, this was easy to pick up and easy to catch. If you want to see the mutants that you're interested in, you can show, and it'll tell you all the ones that survived. It gives you a list, and you can number them and say, for example, show me the first one, and it'll show you what you did. Oh, look, this one. We managed to catch that. Cool, whatever. But the important part is that you can get reports of what you didn't catch, and that's what you use to then get the insight, right? Does that make sense? Awesome. Lots of happy nodding. So with HTML, HTML, what we get is this output file here, which basically we can then explore. I'm very impressed if this is sort of semi-live generated, because I talk hecka quickly. Yeah, with this mutation testing report here, we can see and explore the different mutants. And so let's do that. What I want to do is show you 3 mutants that I didn't manage to catch in my tests, and I want to show you if we care about them or not, right? So the first one here, you can see here what we've done is we've renamed the logger. And do I care about this? Not really. Like, I assert that for me, logging is out of scope of my tests, right? It may not be for you, but it is for me. Another one here, mutant 62. All we do in this one, we can see here, is that we change the value of a constant in our method signature. And that's not an incredibly wonderful, like groundbreaking change. It's not something I personally care about in my test code either. But this is one I do care a little bit more about. I'll highlight it here. What we've done is when we instantiate different classes, we're actually not instantiating stuff to do with our voice API, and it's still passing, right? So it's like, whoa, are we not testing our voice API? But we are. It's just that we call it directly. We don't call it in this way. But our users might call it in this way. So actually, this is one I do care about because I think, and I assert that maybe actually we should be testing things the way that the user is running them, right? So this is not, maybe my batteries are going. Maybe that's it. So with this, we're checking, this thing here. When I check my mutants, we caught a certain number of them, and we caught about 75%, right? And I ask you, this is a genuine question for everybody here. Is this a good number? Is this a good score, 75%? I'm seeing a lot of shrugging. I mean, that's the correct answer, so I'm glad I'm seeing a lot of shrugging, because that is the right answer, right? I think 100% doesn't make sense, unless I manually go through and incredibly fine-grained work on exactly what everything is going to be. 100% is not relevant to me. What's relevant to me is the insights I get. And so when I get started with this, I'll just explain what I did, and hopefully these little tips will help. But I'd say start locally, start small, right? Maybe if you've got a larger project than me, you might want to start with a subset, and you can exclude certain modules or certain parts of your test base. You can also tweak for performance after that, so you can, for example, exclude tests if you don't need to test every part of your test code. If there's auto-generated code, you probably want to exclude that as well, so do think about that too. And now, thank you again, Dali, for the next slide, because I can't even remember what the prompt I gave it was, but running off your machine. My goodness. Wonder what this could be telling me. What are they trying to tell us? What aren't they telling us? However, what I'd like to do is just quickly explain how to do that. So why would you do that? Well, it takes some time to actually run these things, right? When you actually run these things, when I ran mine, really small code base, just a couple thousand lines, it took me 20 minutes to get through this, right? Using cloud resources it's just better because it's maybe not faster, but it means you can do other stuff with your machine, and it means also that you can use different platforms and versions at once, which is really helpful, right? Especially if you expect your code to vary. So what I want to do is show you a quick example of that. So here, this is my open source code. It's my mutation test in GitHub Actions, right? I've got a trigger that I run, and I run that manually, and that is a choice. I'm not running this on push or PR. I'm running this manually when I select it. We'll talk about why in a bit. But when we do that, what we do is we get a test report, which gives us the HTML output from earlier, so we can look at all of our mutants. So how did I do it? Well, actually, before we even get there, who's looking at this and thinking, this guy doesn't seem all that smart. I reckon I could do this. I'm going to go home and try. Who's thinking that right now? I won't be offended. Go ahead. I'm pretty dumb. I'm seeing a few hands. I like that. Don't worry. I can't see you. You're unmasked. It's all good. But yeah, I mean, if you're not, that's fine too, because I want to show you how easy that was. Because there's no magic. I'm not doing any magic, right? And I want to show you how easy it is so that hopefully you'll feel like you could do it too. So how do I do it? Well, first of all, I'll show you GitHub Actions, but you can do this with anything because basically because what I'll be doing is something a bit scripty, and you can do this with any CI system, right? What I did, 35 lines of YAML, implemented this fully. That's it, right? So I promise you it's not super, honestly, go to my repo, copy paste it. I don't care, right? But what we do is, first of all, we set up a job. I run on Ubuntu. And I run just one version of Python because I don't expect my code to vary too much between versions and platforms. Yours might, so think about changing that if you need to. And then here we've got the checkout. First of all, we check out the code, and we install Python into our runner. And then we actually set up our requirements. We include mut and nat. Once we've done that, we do a mut run. And we had no progress. Basically, that's a flag that means that our logs are still legible, which is what we want. And the CI flag there just basically means we return a sensible error code. And I'm proud of that because it's my only contribution to mut, but hey, I'm still happy with it. Moving on, we save our HTML output, and we upload that so we can get hold of that ourselves as well. And that's it. That's literally the full implementation of this entire thing, right? That's literally all we need. And so I'm hoping that this will show you that this isn't a crazy thing to think about doing. This is something that is quite sensible to explore, right? Even just have a go, try for an afternoon, Just before we wrap up, just my final bit there, just to talk about manual versus automatic triggering. So I said that I run this stuff, and I run this stuff manually. I don't run it on a push or a PR. There's two reasons for that, really. One is that I don't want this to become another number that I optimize for. I don't want this to become, better not get my code coverage up above a certain number. Let's get my mutation score up a certain number instead, right? That's the same issue. You've just abstracted it, right? So I think, personally, that's one reason to do it manually. But the other reason is that I don't want it to run every time. Like, there is some caching that goes on. Some of these test results can be cached. But the fact is that, I don't care too much unless I maybe add, a whole new feature or something. This is a, it's a hold your finger into the wind test. It's like how much of my test code is looking like I'm still on the right track, right? As long as the number isn't going down a lot, I don't need constant reports about it, right? With CI stuff, if you do need to use multiple OSs or multiple versions, do think about doing that because it might be helpful to you. But yeah, honestly, I just really encourage you to try it. Really, this is what I'm trying to get across, is that it's just a cool, fun thing to do in an afternoon, and if it works, awesome, But what I would also say is, just to summarize here, that mutation testing, what it does is, as we've said, it's a way of testing your tests. I think there's a person in the back there who said that. Thank you. It's a way of testing your tests. It helps you to beat Goodhart's law for test coverage. And to do that, it helps you to abstract and focus on the code that is important to you, what our tests are doing, and how they're doing it. That's what we care about, right? When you're doing this, you want to start really small, and you want to run, if you can, in a CI system so you can get these things done asynchronously. But I think the final thing that I really want to get across to you is that mutants themselves, right? We've been thinking this whole time about penguins, right? And penguins aren't scary. Penguins are cute and adorable, right? But the fact is that these mutants also have a lot of value to us as developers. They're super valuable because they can tell us about how our code's supposed to behave, and they can provide a way of testing that, even though they can't themselves fly and perform that task. They still help us out an awful lot. And so I claim, and what I assert here, is that you shouldn't fear them because you should love them. Thank you very much. So there are some links here. If you have any questions, please tweet me. You can look at the code themselves here, and if you want to try it, it's right here. So hopefully this has been useful to you. Thank you. Right.